Hi, I'm Miss Fung. Today we're going to look at the discriminant. In the last video, we had a look at the quadratic formula. And the quadratic formula was derived from this quadratic equation, and it gave us the solutions to that equation. Given the quadratic equation ax squared plus bx plus c equals 0, where a is not equal to 0, the solutions are given by the quadratic formula. Now we notice something, there is a bunch of numbers underneath the square root. What do we know about square rooting numbers? Well, square rooting a positive number gives us a positive value, square rooting of 0 gives us 0, and square rooting -5 will give us no real solutions. Now when we look at this quadratic formula, if I had a positive number there, then minus b plus a positive number will be different to minus b minus a positive number. So that means we have two answers for x, or two solutions. However, if it was 0, minus b plus 0 is the same as minus b minus 0. So if it was 0, we would only get one answer or one solution for x. And thirdly, if it was a negative value in there, we would get no real solutions at all. This section here has a special name. It's called the discriminant, and its symbol is this little triangle there. So we say when the discriminant is greater than 0, there are two solutions. Remember this section here, if it's positive, minus b plus that number, minus b minus that number, divided by 2a gives us those two solutions. When the discriminant is equal to 0, minus b plus 0 is the same as minus b minus 0, it only gives us one solution. And when the discriminant is less than 0, it's not going to give us any real solution. What does this look like? Two solutions looks like that when we have two x-intercepts. One solution is when it just touches the x-axis, see, only once. And no solution is when it doesn't touch the x-axis at all. Let's try an example. Find the discriminant of each of the following quadratics and state whether the graph of each crosses the x-axis, touches the x-axis, or does not intersect the x-axis at all. So here are the three equations we're going to explore, and to figure out whether it crosses the x-axis, which means two solutions, or touches the x-axis, which means one solution, or does not interact with the x-axis, which means no solutions, we're looking at the discriminant. So let's write the discriminant up there. Now we need to figure out what a, b, and c are. So a is 1, b is -2, c is -4. So the discriminant becomes, so b minus 2 goes in there, minus 4 times a, which is 1, and c, which is -4. Let's evaluate that. So minus 2 squared is 4, minus 4 times minus 4 is positive 16. So positive 4 plus 16 gives us 20. It is a positive value, or in other words, the discriminant is greater than 0, so we have two solutions, and therefore it crosses the x-axis. Let's try this one. Here we have a is 1, b is -2, and c is 4. Plugging it in the discriminant, we get 4 minus 16. This time minus 4 times positive 4 gives us a minus 16. So we have -12. And the discriminant is less than 0. So we have no real solutions, and it has no x-intercepts at all. You can probably guess what the third one is, but let's just do it anyway. So a is 1, b is -6, c is 9. So let's plug it into the equation. 36 minus 36 is 0. So when the discriminant is 0, it touches the graph 1, or in other words, it has one solution. Example 2. Find the values of m for which the equation 2x squared minus mx plus 2 equals 0 has one solution, or two solutions, or no solutions. So how do we do that? One solutions mean discriminant is 0. Two solution means the discriminant is greater than 0, and no solution means the discriminant is less than 0. So let's work it out. B squared minus 4 is c. So a is 2, b is minus m, and c is 2. So plugging that in, we have minus m squared is positive m squared. Be careful with that. And minus 4 times 2 times 2 is minus 16. So now we bring that 16 over. We have m is equal to plus or minus 4. For two solutions, it's a little bit trickier. So we plug it in the equation, same values, but this time we're looking for greater than 0. That means it's solving an inequality. If you've forgotten how to solve an inequality or you need a little bit of revision, click on the little eye and it'll take you to that video. So to solve the inequality, we have to find the intercept, so plus 4 and minus 4, it's the same. Now we sketch it and we figure out where greater than 0 is. So greater than 0 is up here. So we want that line and that line. That line is when x is less than negative 4. And that line over there is when x is greater than 4. Similarly, we can do no solutions by working out the x-intercept. We would sketch the graph again, and we know that less than 0 means this bottom section here. So this bottom section here is the x values between negative 4 to 4. Nature of solutions. For the equation ax squared plus bx plus c equals 0, where a, b, and c are rational numbers, that is, where you can write a, b, and c as fractions, then looking at the quadratic formula, we can see a few things. Now remember, the discriminant is that section there. Let me rewrite the quadratic formula with the discriminant there. What happens if that section is equal to 0 or not? Well, if that section is equal to 0 and these are all rational numbers, we know that that's going to be that section that's gone because it's 0. Now this is full of rational numbers, so the solutions, the one solution is rational. If that's not equal to 0 and it is a perfect square, then that's going to be a whole number there. So then we're going to get two rational numbers or two rational solutions. But if that's not equal to 0 or it's greater than 0, then it's not a perfect square, then the whole thing will be irrational. So we'll have two irrational solutions if it is positive, but not a perfect square. So the discriminant also helps us identify the type of solutions. Example 3. Show that the solutions of the equation 5x squared plus m minus 5x minus m equals 0 are rational for all rational values of m. So we look at the discriminant and we see the discriminant is b squared, so that's squared, minus 4 times a, which is 5, times c, which is minus m. Let's solve for the discriminant and see what we get. So expand that bracket, we get n squared minus 5 times 2 is 10m, and then plus 25. Then minus 4 times 5 is 20, times the minus m is positive 20m. Now let's put the like terms together. So m squared minus 10 plus 20 is plus 10m plus 25. So we can see that that's a perfect square, m plus 5. So now m plus 5 squared is always going to be greater or equal to 0 because m is a rational value. So if m is negative 10, we're going to get 0. If m is any other number, because we have that little square, it's going to be a perfect square. The discriminant is a perfect square for all values of m, and therefore that equation have rational solutions for all rational values of m. Thank you for watching, and I'll see you next time. Bye!